Let's start by asking, show of hands, who is running generative search in production? Is anyone doing it? No one's doing it. Is anyone considering doing it? Okay. Okay. I'm not hoping to influence you one way or another, but I am going to try to give you all the information here that you need to decide on that. And help you know what to look out for. So my name's Colin. I'm the head of technology at Nesh. My team builds a enterprise search and agents platform for heavy industries. And we've been running generative search in some form or another for about 1.5 years. And there's a lot of content out there about generative search right now. A lot of it comes from tool providers, which is great. That's kind of where it has to start. But what a lot of tool provider content might miss is issues with actually using the tool that you have to experience in production or in development. So we're going to talk about hallucinations and defects in general in generative search today. What we're not going to do is just generate a bunch of concepts that give you FOMO like a LinkedIn post, okay? So by the end of this, you should have a pretty clear understanding of what the possible problems are and how we can deal with them. And also, how is this going to look in 6 months? Because that matters too. We're at a very unstable time and things change rapidly. So we're going to start by understanding awareness, the problem. And for the rest of this presentation, we're going to throw out the term hallucination. And we're going to talk about defects. Hallucination is a very difficult term. Academics and philosophers hate it because it anthropomorphizes. And in general, it's just not very descriptive. So we're going to look at two other types, or two other categories. One being unfaithfulness, where in generative search you generate an answer that contains information that cannot be found inside of your prompt, and incorrect answers, which are just going to be answers that are confidently incorrect in your generation for other reasons. So maybe just answers a question incorrectly. It's not making something new up, it's just getting it wrong. And apologies for the formatting. Doesn't look quite normal. So the motivation here should be clear. If this is something you're considering running generative search, you need to be careful. If you're showing bad answers to users, that could impact user satisfaction, that could damage your reputation, as we've seen time and time again with other AI systems. And also addressing these problems properly can help you limit your cost, latency, and improve your security practices by allowing you to use weaker models or models under your control. We're going to start looking at some examples, but first let's kind of lay the groundwork for where these examples come from. So in generative search, you get some query, you retrieve results for it, you select some top answer or top answers, we'll call that our top N. You form a prompt including those answers and your query, and then you generate an answer based on it. This is not a prompt engineering tutorial, so we're not going to spend a lot of time on prompting. There's lots of content you can find online for that. We're just going to use this very simple prompt, which is based on a prompt which was leaked on Twitter from Perplexity AI. So just to give you some idea that this is a vaguely credible prompt for this sort of application. So the way that goes is you're going to have a system prompt if you're using a chat-based model, and then you're going to have a generation prompt. We're going to kind of list out our source text, so what we're generating over, the question that we're trying to answer, and then an instruction set, which here is going to be generate a comprehensive and informative answer of under 80 words for the above question solely based on the provided source text. Use only information from the source text, use a certain tone. If you can't answer using the source text, respond not enough information and explain why. So some key things here are the statements of only use the source text and give the model an option to not respond. These are both super important, and I wouldn't recommend trying generative search without these statements to your model. Another one is set your temperature to 0 for the model. That's pretty widely understood. And then the models that we're going to look at examples from are GPT 3.5 Turbo and Text DaVinci 3 from OpenAI. The reason we're looking at these is because, in my experience, these are basically in another class in terms of instruction following. And generative search is an exercise in instruction following. So if we can find defects with these models, we're going to find a lot more defects with weaker models. So this is just kind of to prove that they happen. And these examples are things that I've encountered while using generative search. They weren't, designed specifically to target these problems. So let's look at a couple. We're going to start with a source text passage for some product information about a chemical, and a question just asking for a definition of the chemical. And on the right, we have our generation text. And it actually looks very good, except what's shown in red there does not come from the passage. And this is with DaVinci 3. So this is not an egregious example. You could easily overlook that, but this is, a nice benign example of this generation not being faithful to the passage, because nowhere in there does it talk about industrial processes or uses. And you can even try this in GPT-4, and you can get something like various industrial applications, similar answers. So we'll come back to this in a bit to understand why it's happening. Let's go to another one. It might be a little more scary. So we've got a passage that is associated with a product, but the product is not specified in the passage. And then we've got a question about, is a product carcinogenic? And the model will confidently answer, no, it's not carcinogenic. But that is simply wrong, because this passage comes from a different product. And you can think of a lot of reasons why this would happen. This is what we're going to kind of focus on as the number one thing you should be aware of. You need your source passages to include the information that links them to the query. Otherwise, this answer in production could have serious consequences, as you could imagine. That's a unsupported and incorrect answer. Let's dive into that one a little more. We can find some more problems if we just add a product name kind of haphazardly in the source text. We get a different answer. This time, it's still not the product in question, but GPT 3.5 Turbo answers a different question than the one that was asked. So another thing to look out for. And in this case, curiously, Text DaVinci 3 handled this correctly. It followed the instruction to say not enough information and explain why. So you will see wide variation from model to model. Okay, this is a question about a property and some physics information. So in this passage, we have chemical properties of a particular product, and we ask, will this chemical freeze at 13C? There is a freezing point mentioned, or a melting point, freezing point mentioned in the passage, and the model correctly pulls that out. However, it's unable to relate that to the actual question. It doesn't understand the relationship between a freezing point and a higher or lower temperature, right? And this one is a little, kind of a similar example. Can I use this chemical in applications requiring pH below 10? And the model gets close. It pulls out, the pH value that we want to compare to that bound, but then says, well, that's probably not, 8 to 9 is probably not below 10. So we're going to cluster these into some categories in a moment, but that's a pretty challenging one that you'll see there aren't good ways around, not easy ways. So now we're going to increase our N from just looking at one passage to looking at more than one. What we'll find is this kind of multiplies the errors that you're going to end up getting. And the way we're doing that is by slightly altering the prompt. And again, this is heavily based on the leaked perplexity prompt, so we're not making anything up here. And we're basically just telling it combine results together, cite source passages, and only cite things that should be mentioned. So I'm not expecting you to read all of this. I'll tell you what's happening here. We have 3 passages that are from a piloted projects brochures table. It looks like marketing copy. I just made these with GPT-3 or ChatGPT to simulate things we've seen in production. We ask which companies have we piloted blockchain with. The answer we get back is that confidently passage 1 has piloted blockchain, but that's it. The other ones have not. However, if you look at passage 3, you'll see that this other company also provides blockchain technology, and it's also in the piloted projects table. Really, there's no good explanation for why it captures 1 but does not capture 3. This is just a defect in generative search that we're going to have to figure out how to deal with. And using a similar set of passages, another example I tried is adding instructions to format as a bulleted list. And what happened with that is our citations disappeared for no reason. So that's just another curious thing that we're gonna identify as being, when you add more complexity to your task that you're giving the model, you can expect more defects. So let's try to categorize some of these defects. This is not an exhaustive list, but we're going to go back and consider the examples and see which categories they fit into. So the first one is going to be memory leak, dealing with numbers, dealing with missing context, general reasoning, and everything else. Some of the other ones that didn't make the cut here were mixing information together and close enough information being interpreted as the thing that it's close enough to, when in fact they're different. So starting with the memory leak, this is the closest to what people traditionally consider an AI hallucination. It's talking about something that isn't there. And in this case, our example was used in various industrial applications, without that being found or supportable anywhere in the source text. And we can theorize about why this happens. The intuition is the models don't follow the instructions perfectly. Okay, use only the provided context fails sometimes. That is an instruction given to the model. And we can also intuit that a probable reason for this is that there is a contradiction between the pre-trained learning task of autoregression and the downstream instruction tuning task, right? Because on one hand, this model is trained to predict what comes next on the internet. And in the case of a chemical, that's going to be used in various applications. On the other hand, you have these downstream training tasks that try to stop the model from doing that. And that's a super black boxy interaction between those two training tasks. So you're probably going to be at higher risk here when the model has confident memory about your topic. And can't support that with facts other than intuition at this point, right? But if the model has a lot of knowledge about a topic and you ask it to only say one thing about a topic, it's probably going to be more tempted to say more than if it didn't know anything about that topic. Missing context, super dangerous. This is how we got the not carcinogenic result. Some of the causes here are, first and foremost, if you don't have the entity you're asking about in that passage, you're doomed to fail. If you ask a leading question and it just sees a isolated, non-contextualized body of text, you can't necessarily expect it to know answer every time. Don't put it in a situation like that. This can also possibly be due to, you know, these models which are tuned on reinforcement learning task are kind of biased toward being helpful, right? So there's almost a little bit of a bias toward, you know, maybe what you meant is, oh, that's probably relevant to this topic or entity, so I'll talk about it anyway. Numbers, just if you can avoid it, don't do generative search with any type of numerical operations. We saw this with 8 to 9 being less than 10. We saw this with freezing points. The freezing point one, you could also consider missing context because there is a physical concept there of what a freezing point is, what it means to be above it and below it. Now, some of that is probably contained in the model, but if you can add that context, you're better off. But with numbers, just stay away from them if you can. Close numbers might be considered similar, and any number handling is going to introduce risk into your generative search application. Okay, general reasoning. We see these reasoning errors or instruction following errors when we get to more complex commands, more complex instructions to follow, and more complex inputs. So when you're attending over 5 passages, a lot more is happening or has to happen inside the model for it to get that right than if it's just looking at one. And you know, there's other types of reasoning that I'm sure you can find these models are bad at. But keep your complexity down wherever possible, and your ambiguity. Kind of the same thing with these. Okay, so now the fun part, we're going to talk about how to prevent these. The first step is kind of understanding you've built generative search. How do you evaluate it? How do you know if it's working? And then how do you choose, you know, a prevention technique for these defects? So here's just a proposed workflow for how you can go through that iterative process. So you're going to start with the basic system, which is basically you choosing, all right, I'm going to do, you know, my top 1 or my top 5 or dynamic N, and you're going to form an evaluation data set. We'll talk about what that can look like in a moment. You're going to smash those together and see how it does. That's going to involve some human labeling, some human interaction. And then you're going to understand what types of defects did this system produce. And that will help you choose a safeguard technique. It's not going to be a super simple one-to-one mapping of these categories we looked at in a safeguard technique, but it can help get you closer. And once you choose one, you're going to implement it and reevaluate. The safeguards in the box there, all of them are viable. We're going to talk about all of them, but really that top row is where you're going to want to spend most of your time. The bottom row is a lot more complex and in some cases theoretical. So let's talk about that evaluation step. Or actually, let's talk about what the basic system looks like. So we covered these prompt statements, only provided context, call out not enough information, model configuration, and who or what is a passage about. I wouldn't even recommend trying generative search if you don't have confidence that the subject of your passages is explicitly written in your passages. So we're going to keep coming back to that, but that's a really important one that is easy to miss. Okay, evaluating a generative search system. It is a system. This is not a component. It is not a model. Ingestion is part of your system. Retrieval is part of your system. Generation is part of your system. So there's a lot of kind of states here, and you can conceptualize it different ways, but we're going to talk about it with the input being a query that passes through, an ingestion system with a data set, retrieval system, and a generation system. And the output is going to be a generation and a set of sources. So those sources are your top end that you attended over, or maybe even your whole set if you'd like to do that. So it's tough to perfectly track everything, and if you try, you probably never get started, because in that case you'd want to be capturing your ingestion and index versions and retrieval versions. So just start by coming up with a dozen examples of query, your top end, retrieved results, and the generation. And what you're going to do with this is review those manually and try to point out whatever defects you can, and then look at the categories, look at the safeguard techniques, and pick one that fits it best. You can also use language models to do some of this evaluation. OpenAI does this with GPT-4. Obviously, there's problems with that. I wouldn't recommend that to anyone starting out. That's more of a big scale thing. There's not a lot of tooling for doing this evaluation process. That's something that will hopefully change in the upcoming months, though. I think we've got, just to tickle your curiosity, this is what OpenAI did to automatically evaluate and generate a synthetic data set for addressing their closed domain hallucinations. So we won't go into that, but basically GPT-4 is really smart. This might work, but everyone's doing GPT-4 data sets and evaluations now, and we still don't know how close those are to what humans actually do. So grain of salt. Okay, and then safeguard techniques. So ingestion and indexing, start here. Most important thing, your generation quality depends on what goes into it. You need to have some sort of link between your query and your context. So an example of when that doesn't work well is you ask, when was Napoleon born? You get, he was born in 1769. Do you know that that's actually the answer? Well, the model might think it does, but really what you'd hope is that it would say it doesn't. So what you want to give it is something like Napoleon was born in 1969, or a heading from my document, Napoleon Bonaparte passage, he was born in 1769. So just use that as an example. Think about your data and whether you can establish that link between what people ask about and what's in the document. That can depend on, in your ingestion process, things like your chunk size. If you're using too small of chunk size, you'll often miss out on valuable context that you need to make that link. And maybe you're not extracting metadata and appending that to your passages. Things like headings, file names, these could all help you. They could all be the thing that saves you when you get a question that doesn't have that link. And you might want to also look at like topic or entity extraction within your documents if you can confidently apply those to a passage, and more particularly to a statement. If you do that wrong, that's worse than nothing, right? Because then you're going to be confidently answering, and the model would have no way to know that it shouldn't be doing that. Okay, the next one, and the next most important one, is retrieval and results filtering. Still a system we're talking about. Ingestion is where it all starts. It has to go through retrieval next. And as we saw in our examples, if you get results that are close to talking about what the query is about, the model may get that confused and that could cause a defect, right? So this is a weird situation where getting close but not exact is worse than being super wrong. Because in super wrong examples, the model knows what to do, knows this is about something else, so I'm not going to answer using that. So one caveat is if you're running naked vector search, it's really good at getting those close things. So definitely consider adding in filters, add some must-match filters in there if you have entity information. Yeah, some other techniques you can do, matching your entities in the query and the passage, exact matches of particular query terms. You could use a re-ranker and some sort of cutoff threshold. The re-rankers nowadays are, not quite as smart as these models that are doing the generation, but that could still get you better. It could get you closer and filter out some of the noise of like close but irrelevant. And finally, you may want to use language models to do some filtering step. That's going to be expensive and complicated, but that's an option as well. Okay, another safeguard or technique you can use is prompt engineering. Could spend a lot of time on that, but we're not gonna. Read about it online, some best practices. Use the workflow with evaluation process, so you're not doing this blind. If you just randomly start changing prompts, you're probably gonna introduce new defects on questions you're not looking at. It's challenging to test it. It's like it's a tuning problem. So there's some tools out there to help you with this, but they're not really there yet. A good technique to use is one-shot or few-shot prompting. This really helps guide the model. Big bang for your buck there. Recommend that in a lot of cases, especially if you're trying to control formatting. Don't just tell the model what format to use, show it an example in your prompt. And if you're doing really reasoning heavy stuff, use chain of thought prompting. Look that up if you're not familiar with it. It's pretty cool, but don't expect that to solve your numbers problems. Some caveats. A lot of the models right now are non-deterministic. Like the OpenAI models, you can get different answers with the exact same prompts from moment to moment. I hear a lot of people using GPT to make prompts as if GPT kind of like knows what makes a good prompt. This is not the case. GPT doesn't know about itself beyond a system prompt that says you are GPT. It's not trained on content from the last year of like, here's a prompt that worked for me, which is what you would want it to be trained on. So it doesn't know what makes a prompt better or worse. It can write nice English language for you though. This system prompt is not super accurately followed in a lot of these models, mainly because in the training environments, they're taught to generalize over the command prompt and not the system prompt. So usually system prompts are kind of, this is my understanding, they're probably left static most of the time. Like in ChatGPT, for example, you're interacting with a model that never changes its system prompt, except with a date. And then the model versions you use, if you're going third party, will change unexpectedly. So just be ready for that, and don't expect the playground models to give you the same answers or be the same version as an API model or a cloud service model. So there's tooling that's hopefully going to improve for prompting, but overall it's cheap, but if you don't scope it narrowly, it'll get out of control. Okay, UX and guardrails, you should always be considering this. How are your users interacting with these generations? You're never going to be able to prevent 100% of the defects, and in some particular use cases, the risk of a defect might be super high if you're talking about danger and things like that. Additionally, in some domains, there's a higher risk of defect occurrence if you're dealing with a lot of numeric operations, right? So if you're able to identify when those use cases occur, then you could classify them and handle them as out of bounds. So if you understand that the user's trying to do arithmetic, which you shouldn't be doing, then you could, classify that through a variety of methods, and then give them an alternative, right? That could be warning them, hey, you probably shouldn't trust this, doesn't do well on these operations, or you could just not answer, refuse to answer. The reinforcement learning from human feedback is also what ChatGPT, for example, uses to introduce these guardrails, but that is a huge effort version of this, so I'm guessing most people aren't going to be interested in that. Yeah, so some available methods there, and on the left, a example disclaimer of just kind of why this isn't perfect and why a user should be wary. Okay, tool usage. If you can identify certain out-of-bounds operations like we just talked about, you might be able to introduce a tool that can be used to solve this problem. This is going to be a ton of work, so you better be really committed toward going towards agents to start using tools, but that could be a calculator, Wolfram Alpha, or a code executor, among other things. Some resources here that you can explore if you like, but this is a huge complexity. But if your requirements are committed to solving numbers use cases, you're going to need to do something like this. Okay, you can generate things in different patterns. Well, all we've looked at so far is generating your results all at once. We saw how that can introduce errors very quickly when you're generating over multiple result passages. So one option you have is to generate passage by passage, or on maybe 2 at a time, just a smaller chunk, and then do an aggregation step afterward. Aggregation could be, another generation step, or it could be listing it as bullets in a simpler way, and also throwing out things that say no answer. It's a good practice. Supervision systems. This is, something that verifies your results. These are kind of coming up right now, and there's a few ways you can attempt them. We'll talk about language model reflection and faithfulness classifiers. There's bound to be other methods out there, probably some symbolic methods, but they're not mature or widely understood or useful yet. So this is like cool, but it often doesn't work. I wanted to have an example for you of it, but it was just too hard to get it to work in a demo environment. And let's look at those first two detection methods. So language model reflection is using a language model to spot the mistakes that the generation process may have made, and then take action. You can get rid of that defect answer, or you can try to regenerate, although that runs into the same risk. And this might be more feasible if you're using a more powerful detector than your original generator, because you would expect it to need more strength, although intuition fails here a lot, so don't overthink this stuff. And this is not a reliable method right now. It's not something I would recommend at the moment until it's better understood, and it gets you into some nice circular reasoning questions. Faithfulness classifiers are kind of on the way up right now. You can't go out and get one, sadly, but the idea here is you feed in your generation and the source documents, and then you train a classifier to predict a score of how faithful they are. So this is essentially identical to a cross-encoder, or cross-encoder used for natural language inference. This is very similar to the natural language inference task. And I'd caution about using those old NLA models from a couple years ago, because what we're asking these generative models to do now is way more complicated than the benchmarks and training sets that those NLI models came from. So yeah, be wary of the weaker models, and there should be some news on this soon. Haystack or DeepSet Haystack are working on a model And that should be open sourced at some point, maybe in the next couple months. And the last levers that you can pull to reduce defects, we've got model selection. So this one is pretty self-evident. Stronger is better, but it's not going to, we're not at the point yet where there's a model that can eliminate defects. That just doesn't exist yet. Even GPT-4 produces plenty of defects in addition to being very expensive to use. So how do you pick a model? Right now, there's not a great set of benchmarks if you're trying to shoot for a certain level of performance. In generative search, we haven't even been able to define what is a certain level of performance. So that's on the way, hopefully. But you can look at benchmarks for question answering and instruction following data sets. That's what I would recommend. And most importantly, try things out. Intuitively just feel out how well models can follow instructions. And expect weaker models to need more safeguards. So training is probably a boondoggle in most cases. OpenAI has trained a lot of hallucination out of their models, but it's still a problem. So if they can't solve it with millions of dollars, it's unlikely that you can't. So beware of that, but there are some ideas here that are listed. So with that, let's look at where we're going in 6 months or a year. One trend is stronger models, of course, with GPT-4 and a proliferation of other third-party models. Interesting result from their release paper is GPT-4 is 29% better at preventing closed domain hallucination than GPT 3.5. So that's not 100%. That's the main result there. And RLHF-like training can, it turns out, damage your number handling. So as we get better at certain things, we might lag behind in these models at other things, like dealing with numbers. So there's a concept called mode collapse that's related to that. So look out for stronger models as they get cheaper and faster. And weaker models are getting better too, especially the open source ones. So this is something that within the next month or so, you're probably going to have a viable alternative to, viable alternative to a GPT 3.5 turbo model, mostly with the commercially available reproductions of Llama. So there's some great stuff coming, and these weaker models are going to have more defects. It's going to be more important to solve them with good safeguards so that they're safe to use and can be adopted widely. And there's a lot of research and tooling, generative search, poorly understood concept so far. So hopefully we get more tooling and more interest from academia and corporate research areas. And that's about it. My name's Colin. I work out of Detroit, and yeah, I really like this generative search stuff and been pretty heads down in it for a while. So if you'd ever like to chat about it, I'm happy to.
We might have time for one, maybe quite. All right, Max. All right.
Colin, thanks for the talk. That was really great. I really appreciate you diving into this stuff. My question is there like a metric that you use to, get a number to say how accurate something is? Are you just classifying all these defects as false positives and using F1 or something like that? Any comment on that?
Yeah, that's about all I'd recommend for now, is basically defect or not. If you wanted to, and then like doing an F1 on top of that. But if you wanted to, you could look at categories. But for now, it's probably good to start with, is this a defect or not, as labeled by a human? So something simple.
Yeah, we got another time for more questions. So, all right, Trey. Is that a yes? All right. I might just camp out in this aisle.
Go to a fun slide.
Thanks, Colin. That was great. So you didn't go into this specifically, but One of the challenges with GPT-4 and a lot of these models is there's a lot of engineering going on right now around creating the prompts, but the prompts leak pretty badly. So like, I won't name the companies, but even some of the companies you referenced, their entire application, you can basically ask, hey, how is your prompt structured? Take it and go create a competitor in 30 minutes, minus any of the other engineering they've done. So how do you see that evolving, or controls around that evolving, so that actually using your product or other people's products, the IP can't just be stolen?
Sure. Mainly, I think any company that considers a prompt to be a significant source of IP is probably going to fail. It's a couple paragraphs, right? So there's that. In terms of how to actually stop it, there are techniques like I think OpenAI has gotten really good with RLHF at figuring out when you're doing that and stopping it. You could even just add in, guardrail classifiers to understand if someone's trying to understand what your prompt is and do a refusal to answer. So, yeah.
Do we have another question? All right. See? Pick the right row to be in.
Firstly, thanks. That was such a great overview of all these things and really awesome. So I kind of picked up like a bit of like cynicism about tool usage from the tone of it. And one tool that I'm very curious about is like the Python REPL and how you can have it write code and execute the code and see the output. What do you think about that kind of tool usage?
Yeah, I actually love tool usage, and I'm working on building a lot of that right now, but the complexity should not be understated because what you're building is not just a subsystem, right, that does a particular task. You're now also dependent on your ability to choose when you use that subsystem and your ability to interpret the output of it. So it's like another, if there's like search and then generative search is another level of complexity, using tools is maybe 2 more levels of complexity. That's just how I see it. But tools are the future. If you have the investment opportunity for, spending your time on tools, then go for it. But you got to commit.
Okay, terrific. All right, I think that's what we've got time for, but keep other questions coming on Relevance Slack. All right, thank you very much, Colin.
Thanks.